Okay, what do we have for the oxidation numbers for the cation atoms here? Why is hydrogen plus one? Because hydrogen is being paired with a nonmetal. Okay. And the chloride then is forced to be a minus one. And then the name of this? That's driving me crazy. They must be trying to center everything. Huh. Yeah, whatever. I'll figure it out. Okay, the next one? The sulfur? What about it? And what's its charge? It's in that oxygen column, right? So then in a typical ionic compound, it's going to be a -2 charge. So what's the cobalt force to be? +2.
Cobalt sulfide.
Not quite.
About 2 sulfide.
Okay. Next one? What do we got? Okay. And what's this one?
Sulfuric acid.
Okay. Next one? Because my oxygen is a -2, my iodine is forced to be a +7. Because this periodate polyatomic ion needs to have a leftover -1 charge, and if I have 8 negatives from the 4 oxygens, then the iodine will have a +7, canceling 7 of them out, leaving 1 leftover negative. And then this is periodate. And then this last one? If the iodine is a -1 charge, then the manganese is going to need to be a +3. So then this is manganese 3. I don't know why I just wrote a 3 in there. Great. Manganese 3 iodide. If a molecule is polar, what's occurring? Why? But why? So what does that do? Okay, so how about How about uneven sharing of electrons in a covalent bond? So then which molecules can't be polar? Ionic. Because this is about uneven sharing, and ionics don't share. So the ones that cannot, those are ionics. Okay. Draw the Lewis structure, draw the 3D model, draw the Vesper structure, name the structure, and indicate if it mixes with water or not. Okay, so we've got so there's 4 electrons here, there's 1 times 3 here, and then there's 7 here. So I've got a total of 14 electrons to take care of, and then there's 8, 2, 4, and 6 gives me 14 total electrons. So there's my Lewis structure.
It doesn't matter like where you put the electron.
It does not matter. So the molecular structure for this is what? It is a tetrahedral. Very good. So there's the molecular structure. There isn't a Vesper structure. Why not? What is valent, or what does the Vesper structure deal with? Valence electrons that are on the central atom. Are there any unpaired electrons in the central atom? Nope. So then we don't worry about it with this one. Okay, and so tetrahedral. Okay, so for the, oh, and does this mix with water? It does, because what we have is this one fluorine dragging electrons to this side of the molecule, making this negative, and this side over here positive. So this would mix with water. Okay, so nitrogen has 5 valence electrons plus 3 times 7 valence electrons, so we have 26 electrons to deal with for this nitrogen triiodide. And so I'm going to put the nitrogen in the middle and the iodides around the outside. And if I give all of the iodides 6 electrons, then I've used 24, and then the last 2 electrons go right here on the nitrogen. And now I've used 26, all 26 of my electrons. So is there a Vesper structure with this one? Yeah, because that central has a lone pair. So what's the Vesper structure look like? How many things are around the central atom, including the lone pair of electrons? 4. So I've got a lone pair of electrons, a bond, a nitrogen, and then I've got an iodide. I've got an iodide. I don't know why I just drew a hydrogen. An iodide and an iodide. Okay, so there's my Vesper structure, and the Vesper structure is going to be tetrahedral. And then I've got, what's my molecular structure going to be? I'm sorry, say it again? Trigonal pyramidal, yep. So when I'm doing the molecular structure, it's just the nitrogen and the, I did it again, and the 3 iodides. And then that structure is trigonal pyramidal. And is this guy going to mix with water? The electronegativity for the, what do we have down for the nitrogen's electronegativity? I forget what the value is. nitrogen should be 3. And then the chlorine's only, this is iodide, sorry. 2.66. No, you're right. It's only 2.66, so I'm not going to get a skewing here. All right. So no and yes. Okay.